All right. It's 2 p.m. on the dot in London, at least. What time is it in Toronto, guys?
9.
9.
And it's 9 a.m. in Toronto, and we are ready to kick off our third session, actually fourth session of the day, with Jenessa Man from Arup and Reynold Chan from Speckle. We're going to talk about building structural models with Speckle. So something we haven't really seen a lot of before. I'm really looking forward to this presentation. Over to you guys to introduce yourselves a bit better and to show us some cool structural stuff.
Yeah, thank you, Mateo. Oh, okay. So I guess I'm really awkward about these presentations. So let's just start. I'm gonna start sharing my screen. Boom. Can everybody see that? Hopefully everyone can see that. Cool. Oh, this is way too early. Let's start from the beginning. Cool. Yeah. So I guess we can read a bit more, but I guess we'll get started.
Yeah.
Cool. You gonna start us off?
Sure, yeah. Well, hi, everyone. Thanks for joining our session. We're pretty excited to share some of the recent V2 work that's been going on for structural. So hopefully we'll share a couple kind of cool demos of different ways to build structural models enabled by Speckle, and hopefully kind of pique everyone's interest in continuing to grow kind of the structural aspects of the ecosystem. In terms of introductions, as Matteo said, my name's Jenessa. I'm from Arup. I'm a structural engineer turned developer. And actually, luckily, I have been a colleague with Reynold before.
Yeah, I think the luck is more on my part. So I was also, before I joined Speckle, I was a structural engineer. I was an intern at Arup in the Toronto office. So I actually worked with Jenessa as well. And now I'm a full-time software developer, engineer at Speckle. And I'm mainly helping out with building the structural connectors with Speckle. So Speckle will be releasing and supporting some of our own structural connectors, and we're excited to show you what we got here today and what we can do with Speckle. Yeah.
So it's a bit of like a tongue-in-cheek question. How many ways can a structural engineer build an FEA model? But honestly, if you ever want to have a really, really long, drawn-out conversation with a bunch of engineers, this is probably a really good kind of probing question for that. So we were joking that if you ask 3 engineers, you're probably going to get 7 ways back. And I mean, all of these ways, it's just very much indicative of the fact that the workflow is spread across different tools. The data itself is spread across different tools. And this is where probably a lot of the strengths of Speckle can really shine if we integrate into our workflows. Reynold, are you able to click? Yeah. Yeah. So of
Yeah.
course, I think you guys, all you guys watching are familiar with a lot of these tools here and the web of kind of processes for building a model and from building a model to interrogating the model to sharing the results of the model encompasses so many different spots and so many different kind of applications that it does make it hard, especially too, for one to collaborate. So hopefully that's one of the things that we'll be able to showcase in the demos.
Cool. So specifically, if you haven't been attending any of our sessions and you're still confused what Speckle is, you should be attending most of the sessions. But for structural engineers at least, what is Speckle? The age-old question. So Speckle is really the open source data platform for AEC. It really, what it means is that you can host your data onto Speckle. It acts as a collaborative, multidisciplinary common data environment, which is really big words, common data environment, which means that structural engineers can turn their data from their ETABS model, from GSA or from ETABS, into this common data environment, which is stored with the rest of the Speckle connectors and interact with them. As of now, we're planning to work on and release a ETABS and GSA connector, and we'll be planning to support further different types of structural software in the future. And by doing this, you can integrate with other commonly used AEC tools, so like Grasshopper and Revit and other ones. So that eventually you can actually collaborate with other people in different disciplines. And Speckle enables that for structural engineers, which is very, very important in our common workflows, as we often our industry is an industry of collaboration and we're not working in silos, right? So, yeah.
So, what's in it for you? How can Speckle help? So I think there's a couple immediate benefits that Reynold and I see. And obviously, as he's just explained, cross-vendor interoperability across software that we use for different aspects of the structural workflow are enabled with Speckle. Also kind of provided automatically with use of Speckle is revision tracking. So the ability to kind of understand and track and manage the evolution of your workflow and your model data. And of course, what we're going to kind of jump into right after improved model building. So the ability to leverage other tools, link data between those tools to make your model building process more efficient and faster. And of course, as all this data is being made available, but also still being tracked, this does make it such that it's much easier for you to share your data directly with collaborators. So again, kind of this idea of having a collaborative and multidisciplinary data platform enabled by Speckle for a structural workflow. And I think from our perspective, all these 4 points, they really do point to kind of a larger also underlying benefit of obviously building a foundation for, further workflow automation for structural workflows. And so kind of a nugget of wisdom from past Reynold there. But I think his experience with a lot of the model building processes previously in industry is that a lot of it can be quite manual. So if we could, save some hours and save some of past Reynolds kind of sweat and tears, that is certainly kind of a a worthy cause.
It's a bit too late for that, but we can say future
Yeah, the future Reynolds, the future structural
aspiring
engineers.
structural engineers
Yeah.
mainly. Cool. So basically, one of their main workflows, yes, that we have is going from Rhino to structural. Yay! So architects love to use Rhino software, and structural engineers do not necessarily. But the idea and the concept behind this is like so. And I'm going to be showing a recorded video for this one because this one actually takes up a while. Uh, but mainly, if this works, well, it should work. It's a recording. So if this still doesn't work, anyhow. So, and this is me figuring out how to use recording software. So, in Rhino, architects love to use Rhino. They use it for geometry every so often to build their models. And geometrically, it can end up in creating very cool structures that structural engineers don't really care about. Really, to be honest, we just care about lines at the end of the day. So this is all very interesting for the architects. And what's cool about Speckle is that you can see that we can simply just grab the data from Rhino directly itself, so the architect can filter out and go by uh, the data they want to send. In this case, I put all the lines of this tower segment that would never exist. To be honest, this tower segment, if a structural engineer were to build this, they would never be able to build this manually by hand, and that's the most important point here. So you can see there's around almost 1,700 line elements that the structural engineer would have to draw inside the model, and Speckle here is now just taking that and it's being shown in a viewer. And in our viewer, you can kind of explore around with the data itself. I'm just going to go into tabs directly and make this very not interesting and not explore the data and trust that the architect gave me the right file. And I'm going to build a new model in here. To pre-built settings, Canadian settings. I'm just going to try and grab that same model back into E-tabs and trying to get all the stick geometry into E-tabs. And now so the benefits of doing something like this is that by having this workflow, now architects can actually send you stick models, and you don't have to collaborate necessarily through these painful PDF documents or painful drawings, and that can be making the workflow go by a lot faster. You can see I'm just grabbing back the same screen from before, and I'm going to fast forward to the end. You can see that here there's a bit of version control, so you can see kind of all the kind of past commits and see what kind of the progress of the structure and the model as it progresses through. So if the architect wants to change something new, and now the conversion process, because this is still very new, it takes quite a while. So we can skip to the end of this video and see the thing getting loaded into eTabs. And the same thing is done for the GSA connector. So quickly, if we go over back into here and pop this up. Here, Jenessa did something more fancy, and where you can even pull the same script back into Grasshopper, and she assigns sections into all of these aligned with each of the beam elements. And by doing so, she sets a screen. Again, you can access the screen viewer onto the on our Speckle server, and by this can be shared with anybody, so you can collaborate with anybody. And here you can see all the properties. It's a bit fuzzy, but that's resolutions for you. And actually, it's just opening it up in GSA, grabbing the same materials, and she's gonna grab it. It's gonna convert, and magically, I'm trying to time this. Boom! There you go. You got your entire model inside here with sections. And if you were to do this by hand, past Reynold would have hated you, probably threatened you, probably as well, and not talk to you for a good week. So we can explore the screen a bit in the server and see what you get to play around with inside here. So inside the screen is nothing much. In the viewer, you can, it's like any 3D viewer, you can take snapshots, take a select view. Here you can add people to the user and add people to as collaborators. So you can add architects, as we were saying, architects can add you, and you get the collaboration aspect that you could never really have before. And you can even see the revision histories. So as people are going through and changing the model through time, you can see what the model progresses. And before, you could never really do that. You would have to go through and check each model individually. And that's a big game changer, really. And here you can see and explore the data itself and see what it's all about, really. And now the next workflow. Oop, this went to hidden slides for some reason, which is very terrifying. So the next workflow that we're going to be showing that you can do is stuff you can do for this with what you can do with Speckle is you can do sending parametrically generated geometry from your Grasshopper scripts to your structural analysis model. And here we're going to be doing a bit of a live demo, so hopefully everything works. And we're going to see this. So what Jenessa will be doing is she's going to be sending us 7 points from the Rhino world. You can share your screen for that as well, Jenessa, if you want. And then I'm going to be receiving those points inside the Grasshopper script.
Yeah, let me get my screen up.
Yeah.
Yeah, I mean, so this is very much. Hopefully that worked out. Did that
Okay,
load
people
through?
see your screen? Yeah.
Yeah, perfect. Okay. So yeah, I mean, the idea that we wanted to kind of demonstrate with this one here is that, I mean, we're essentially setting out points for laying out the structural model geometry. So we wanted to kind of just do a bit of an example of something which is very much kind of a core introductory or preliminary part of the process. But the overall kind of structure as well, as you can see in the first demo, in the second demo now as well, is that we're really kind of enabling these overall workflows by combining all the connectors that do exist for Speckle. So I'll open up setting out points, and this is a very kind of simple script here. So not so much focused on the structural. This is using just the Speckle connector for Grasshopper to send geometry information to another script, which will then produce the structural objects. And the structural objects, the definition of these objects is based on something that we have added recently to the the overall kind of default objects kit for Speckle. And it's something that we're hoping actually the community will be able to take a bit more of a look at as well, and something that we can grow together. So, let's just say there's some arbitrary points here. And here's a stream on the XYZ server. I'll send that now. And Reynold should now be able to grab those. These will be now the latest commit on this particular stream. So we can take a look. And again, not particularly impressive here, but it's our setting out points. And what's kind of interesting to note here is that our model building is going to be centered on this particular stream. So the revision and the history of it coming from initial kind of setting out geometry to layering in the structural information, and then variations and kind of evolution and iteration of that will be contained here. Reynold, do you want to take the screen back?
We can keep
Or-
both screens on so people can actually see parallel what's happening. So yep, I can see the stream over here, and
Okay.
so you can see that this data is just existing solely in the world of Jenessa. I can copy that screen, paste it in here. I have the setups script already, so I'm going to receive the data, and hopefully everything is happy. And ta-da, I got 4 points. Very helpful 4 points from the supposed architect I trained yesterday, I guess. So I guess, and now we have these 4 points that I can bring in, and I have this really wonky mesh because I haven't layered these points correctly. So I'm going to do this quickly right now and see if I could get an actual truss. So we can suppose that these 4 points are like the 4 points of a roof in our case right now. And because I haven't done this correctly, I'm going to, because I'm not a good Grasshopper user, I think it's like this. Yes. And now, boom, we got a space truss. Look at that. Just like that, we got a space truss in this manner. For a second, we can even change the script so that we could change the amount of divisions we want to have, so we could have more members, change the depth, and play around with it. And huzzah. Right, and that's just something that's very powerful to be able to parametrically define your model. And the rest of the script is now going to be all about just generating that model. So here we can create sections and catalogs from catalogs, or we can create custom sections. So I'm going to be creating my own custom section today for the Canadian sections and creating our own material from code. And then I'm going to send them to a property. And these are all in our structural schema kit that is not has not been shown to release yet, but will be released coming soon. And after that, I can create elements. And then I'm going to send all that to a model and send that to a stream just like that. And the stream will be sent and this conversion, and boom, down. We can view this commit back online and see everything that's on here. And we have this really wonky, cool space truss. And I'm going to share that theme with everybody so we can kind of explore that out. And now here comes the fun part. How do I pull this into eTabs? And it's really simple. And Jenessa can share her screen and pull it as well into GSA. Make a new model in tabs. Save this model as grasshopper. So I can pull this plugin into eTabs, and voila, we got it in eTabs. The screen, the screen is located here already. So here's the screen that we had from before. And now I can just look at it that I just pushed it 2 minutes ago. So this is actually the same. And this is the thing that I want. Make sure that it's always the thing, the model that you want. Press the receive button and wait for it to convert. Huzzah. And reload it, and voila. Whoa, okay. And you can see it. Sorry, that sounded exciting, but you can see that the section properties got imported in. You have all these nice HSS sections. Well, no, not really actually, but the sections. Oh, that's because I believe I actually set into catalog sections. Yes, I set into catalog section. So here there is we do support catalog sections. So I was setting a W360 by 110 for some of the sections, and as a result, you can see that the assignment for them is W360 by 101. Cool. And I believe Jenessa can show quickly now on her screen the same process that into GSA, grabbing this.
Yeah, variation. Because I think so far the examples we've shown so far have been focused on obviously geometry and properties. But of course, we know there's other important pieces of structural information to bring through, including things like loads, and also, talking about extracting data from the model as well, looking at how we want to manage the structural model data and perhaps results as related to the model. So, a variation of Reynold script here, a similar thing in terms of laying out the space stress. So, I don't know, we can probably just do a, don't know, let's just make it bigger. And a similar type of thing. So again, parametrically generated geometry, layering on of structural attributes using this geometry, bringing in loads, and packing this all together to send. So we can send this on here. And on the server, again, very easy to share this data, interrogate each of the elements. For example, in this case, if we're even looking at a load gravity or gravity load, interrogating kind of the load case which is associated with that. And so it's called Blue Bridge. To bring this now into GSA, just bring this up here as well. So grabbing the stream and converting the elements. And there we see all these elements here have been added. Sections are, I guess, a little bit thick, but all generated from, the script in terms of, let's say, loads and things like that as well. Just a very basic kind of self-weight there. And I missed restraints earlier, sorry, so I'm just going to add some restraints here. And obviously not super meaningful, but I just want to show this idea of the full workflow going through. So now, running the analysis with some self-weight. we can see kind of the deflected shape. And then, maybe we decide that this would be a good kind of stopping point to perhaps also send some kind of results coming from this particular iteration of the model. So we can send it to maybe a news stream and be able to then also, of course, share that with other collaborators on the server. So take a tad bit just to send it to the server, but that's just kind of a variation on this workflow that we wanted to show. And I'll drop the links to, oops, sorry. Drop the links to these in the chat now. All right. So I think Reynold, do you want to put the slides back up?
Yep.
Yeah. So I see a question, Calvin, from you related somewhat to this kind of demo, but working with built elements and also structural. So in this case, what we are showing is export of analytical elements, so analytical sticks, nodes, from Revit to the structural analysis model. And these conversion methods are actually sitting directly in the Revit converter themselves. So working with that kind of object is not happening in the structural connectors. In the video here on the side, this is a very kind of straightforward model that I think everyone's seen. It's just the default model, and again, sending the sticks and the nodes. In this case, again, making use of the viewer to be able to kind of sense check and get a good kind of quick check of the geometry. Again, looking at kind of what's brought through in terms of the parameters themselves, and a very similar process for then kind of building the guts of the GSA model from this import as well. So in this case, we've got the properties per kind of the family definitions for these particular members. And yeah, it's just a simple example of bringing in those two connectors and making use of the converters in different kind of connectors. So Reynold, do you want to walk through this one?
Yeah, here's the same thing in
Okay.
ETABS. Or maybe I linked the wrong video because it's something classic I would do. And I believe I linked the wrong video, so I'm going to go quickly look at my video. Here we go. Yeah, so in ETABS, same thing, not much different. It's grabbing the same thing. So same exact thing. You can push it to the screen, exploit the screen data on their and all the properties associated with it. Grab it back into ETABS, just like that. On the screen. And then we can explore that the section properties have been imported properly. So if we take a look at this element over here, we can see it's a 450 by 450 column. And you can see that there's other section profiles that are imported from the Revit family here. You'll look in here, that's their corresponding column. And if you look back at the Revit model and look inside what the section property is, just to show that it is truly a 450 by 450 column and sections are being imported correctly. So that's very helpful. As I can a lot of people can imagine that it would be helpful to have a direct Revit into your structural analysis model of your choice conversion.
Yeah, and this is a nice one too in terms of the directional flow between the analytical model and Speckle. It's definitely something that we've seen already applied on projects within Arup. So definitely a nice one for leveraging what software we use for BIM modeling and what software we want to use for structural analysis. So this is an example of where a GSA model building was expedited from the Revit model for a set of schools in Ireland. Yeah.
Cool. And here's a new workflow that we just thought of.
It's a bonus demo. We wanted to maybe kind of end with hopefully a bit of a bang, or somewhat of one. But we wanted to do something. Obviously, we've been showing different software, more maybe geometry and BIM based, focus and bringing that into structural. But we also wanted to show, kind of some interoperability between the structural softwares themselves. So in this case, I think I'll put my screen back up, and what we're going to try to do is export a GSA model and import that into eLabs.
Yep.
Yeah.
Is this going to be useful? Yeah, I guess. I mean, if you like building your models inside using the geometry for one as opposed to the other, I know personally for myself, I always preferred using eTabs over GSA when I was at Arup. I just did not like the UI design, or if you like GSA over eTabs, or any other structural software over another. At the same time, another big aspect to point out is that we know that there's jurisdiction requirements parts of the world. So some parts of the world might not have certain software approved yet. So if you're used to using your own structural software and this in one version, in one software, particularly, let's say in eTabs, and it's not approved in your country yet, and only GSA is approved, now you can convert your model from a GSA model into an eTabs model, or vice versa. And yeah, that's one big aspect of it as well.
Yeah, and certainly, I mean, for maybe some specific types of analysis where a particular package kind of shines a bit more or has some particular kind of thing that you want to look into, that's always something that might be useful as well, where this interoperability kind of comes through. And I'm still just waiting for the model file to load. I'm actually just going to stop this and start the curse of the live demo. Yeah.
It was gonna happen at one point.
I'm just gonna blame it on that.
Oh, I should have wore get the cat. It's a cat. Oh, okay, the lucky cat. There's a lucky cat, maybe.
Yeah, to be honest, I think I was just a little impatient there. Sorry, I should have loaded this up previously. The pre-recorded videos, they're not yet publicly accessible, but we will share them for sure. All right. Okay, so I guess second time's the charm. So, very straightforward kind of model here, just a stick model as well. But sorry, before I send this, properties, it's got materials. So a large chunk of the base for sharing kind of what's needed. All right, so we can now kind of just jump to the look at that. And, here we have this guy here. Again, not too many elements, so pretty speedy. And, we've organized this, and this is something certainly that we'd be interested in hearing more feedback and opinions on as well. But for the GSA connector, we're organizing the structural data under kind of a design model, an analysis model, and also of results. But in this case, we're looking, at some of the geometry there, and we can see all these kind of 1D elements that come through. So Reynold, to you. Want to try that now?
Yeah,
Okay.
let's try, and hopefully it works.
And then maybe I'll stop my screen temporarily. Oh, okay, never mind, you did.
Cool. Now I can see. Well, can you send me the screen ID?
Yep. It is. It's actually GSA data. So if you pull that one, I think it's
Okay.
the same one actually. You can
Cool.
do that. Yeah.
Okay. You can also put the screen online for everybody else to see.
Yep.
You can see that Jenessa, yep, pushed it real good about 1 minute ago. And boom. And you can even see that we're not lying to you that the sections have come in. Here's the fourth magic trick in the box, I guess you could say. And the section properties correspond to column, which I think if Jenessa can share her screen again, you can see the GSA world. Or we can even explore the screen actually.
Yeah.
These
So
are
again,
catalog
kind of.
sections.
Yeah. Just W sections.
Yeah, and the Canadian, well, I sections for other people. I think people use I sections in the rest of the world, or
Yes.
there's still beam columns in the UK.
But yeah. So we just wanted to kind of show one example there of, some cross-structural vendor interoperability.
Which may or may not be the intended use, but there are options.
All right. So I think that takes us to about actually the end of what we had for demos per se. I mean, we're curious to hear from you guys of these, 4 workflows. Which ones do you see have the most applicability to your projects, to your work? Which ones you'd be most kind of interested in exploring? So, maybe chime in on the chat or something like that. But we also wanted to share a little bit of the looking ahead for the structural side of things. So maybe think about that a little bit, and we can share a bit of the roadmap. Reynold, do you want to jump to the next slide?
There's also, Jenessa, sorry, there's a poll functionality here on the right that we could use.
Yeah, I think only you can use it.
Yeah, I
when
think
it organizes.
it might be, yeah.
All right. So if you paste some options in the chat, I'll pop them in.
Sure.
Okay.
I can do that, yeah.
Cool. In the meantime, looking ahead. So there's a lot to look ahead, right? We've only really started this recently. In terms of there's going to be an alpha release of the GSA ETABS connector coming, and what that means is that we're going to be looking for new people to try and test this and play around with it, and see what they want from it, as well as if there's things they're lacking from it. So the structural classes, we've been talking a lot about the structural object, and that is because Speckle is an open source project at the end of the day. That means that everybody gets to collaborate, and that's the cool part about it. Everybody gets to input into this, and the structural object class is used by all the connectors. It's going to be used by all of the connectors, and so we would love to see you on the forum so that we could hear your opinion about what you want and what you like to see more going forward ahead. And for some reason, one slide did not show. Oh no, it did.
No, that's right. Yeah.
Yep.
And
Sorry, I
so,
forgot the slide order.
oh no, don't worry about it. But if you just jump back as well, just to the previous slide, Reynold. Just a note too on the GSA connector, is that this is also something that Arup is going to be open sourcing. So hopefully joining the full kind of open ecosystem of Speckle. And to point out in terms of the structural classes, we're hoping to do a review of the object model as it grows and progresses, as people continue to use the connectors and also build new connectors on a quarterly basis. So we're not sure if that cadence is the right one, but we want to start with that. So we're hoping to do that first kind of quarterly review with the community and all the kind of structural people who are interested in that, probably in the end of this year, calendar year. Sorry, Reynold, do you mind going to the next one? Yeah, and I mean, just to recap, in terms of the benefits for structural engineers, hopefully kind of the demos were able to demonstrate this, but I mean, obviously cross-vendor interoperability is enabled using Revit and using Speckle and using the connectors that we've been working on, the eTabs and the GSA. And of course, as we've seen, even with the small pieces of sending a bit of geometry, of kind of incremental iteration, all that revision, all that kind of version change and all that is being tracked, and very kind of easy to navigate on Speckle server. And of course, model building, a few different ways for model building, but all using the same base, all generating similar data that can be shared easily with your collaborators. And hopefully this will inspire you to think about how Speckle and structural can be kind of integrated for more structural automation. So yeah, that's kind of a recap in terms of the benefits that we see for structural and Speckle.
So if you haven't joined already, haven't made a Speckle account, go to our main website and make an account. You can see everything on the guide and about other connectors and tutorials. Join our forum and always follow us on GitHub so you can keep up to date to what we're releasing. And here is the structural hierarchy. We're just going to go through this really quickly and explain why this are the logic behind our structural objects are. So when Jenessa was approaching this in terms of how software might interact with each other in the structural world, the biggest aspect of it was how do we what is the minimum amount of information, which is the purple layer required to understanding the model. So, which is in terms of elements, nodes, and releases, and then the green layer, which is talking about all the times specific to the software application. So maybe in eTabs, there's peers and spandrels, which are not supported in GSA, and those are specific to the application. And the red layers is the basic geometry in terms of where everything is built from the Speckle default object kits. And the yellow layer is specific to the project. Is there anything else to add onto this pyramid?
No, except that we've got a blog post already on or a post on the discourse forum. And the reason we wanted to share this is because obviously it's a foundational element of all the structural work going forward. So this is the thing that we want to review together with the community on a quarterly basis.
Yep. And now we will take question and answer. And I guess I'll read about that, and me and Jenessa can start. So let's go scroll back on the top. Is Speckle using the eTabs API? Yes. How? Here's a question from Calvin. How do you see the direct two-way conversion between example Revit and eTabs working, given that the first uses BIM type elements object and the second uses structural objects? So, do you want to take that, Jenessa?
Yeah, so I think, and I'm not quite sure if you mean the fact that, Kelvin, that the beam is, for example, the element 1D in the structural class is inheriting from base as opposed to inheriting from the beam class. I'm guessing that's kind of what you're pointing at or getting at. But in terms of the structural kind of bit, we're not necessarily needing, or from the structural kind of analysis perspective, which is when this schema was originally developed, or what the purpose of the schema was originally developed for. We're looking to represent the kind of minimum amount of data to define what would be useful in a structural analysis software. So in that case, it really is pared down to geometry with structural properties, analysis properties included. And so that's the reason why we're inheriting from, for example, the base object and from the Speckle geometry objects as opposed to from the built elements. In terms of kind of the link between the two going forward, I think we've certainly heard a lot of interest about obviously the one direction of being able to take the BIM to go to the structural kind of geometry, and the approach that we want to focus on first is using kind of the analytical model representation within the built element, within Revit to bring that information through. In terms of the other direction, I feel like that's a bit more of like a harder kind of thing to figure out to coordinate, because I don't know, again, from maybe my experience, the synchronization of how you represent a structural analysis model may not necessarily match up with what you need to provide for the BIM model itself. So curious to continue having that conversation with you, but I think the reasoning is because we want to focus on passing structural analysis information, and that we want to take a look at how we think the easiest route would be, which is to focus on analytical to structural, as opposed to the other way around.
Yeah. The next question we have from Claysons is that is adding structural classes to the Speckle Pi module high on the priority list currently. To answer that question, depends on how much you care about it. And I was not aware that a lot of structural engineers use, I guess a lot of people use Python, but I was not aware that people are building models from Python directly. So if it's a very cool thing, I would definitely love to support that in the future. But currently our highest priority is rolling out these connectors to get them for everybody to use, and kind of supporting their biggest workflow, which we see from the poll is from Grasshopper to structural, or Revit to structural. So those are your two big priorities right now. The next question is it possible to design/define custom data representation to pass along to Speckle? So example, a semantic representation of the geometry description for the direction length material. Yes, for sure. So in our object kits, we are defining basically, I'm not sure if I'm understanding that question correctly, but in our object kits, we are basically defining custom data representations, and we can always extend this object kit to include more custom data representation of certain geometry that we're not happy with. So yes, the answer to that question is yes.
And I just actually shared a related link to look at. It's all about kind of the base object, right? The magic of the Speckle base object. So certainly in the GSA connectors, we're using kind of dynamic attachment of properties for a lot of the things where we haven't necessarily included such properties in the structural classes themselves. So for example, for material model properties. So yeah, already being used in the way that we're handling some of the structural conversions.
Cool. Next question is there any live connectors between the master series to and from, for example? Currently, no. I did not know. I am not even sure what master series is, but there can be in the future. So depends on how much the community wants it. If it's a big need, for sure. Yeah. So I think that's about it in terms of Q&A. We hope you enjoyed it. If you like what you saw, go to the repo and give us the stories already. It helps. And enjoy the rest of the conference for today, and check out the other cool talks.
And I think before you close, the feedback form.
Oh yes, I completely forgot. So we have a feedback form before everybody leaves. Don't leave yet. If you leave, I'm gonna be very sad. Come stay with me for like 2 more minutes. We have a feedback form for you, so you can give us directly your input on what you can give us your contact information, and we'll also give you some sneak peek into alpha in here, and give us feedback about the structural webinar overall, what you want to see in the future for future development. And yeah, cool.
Cool. Well, thanks everyone for attending. We hope you kind of found that somewhat interesting, learned something. And yeah, very keen to continue the structural conversation. So please come get in touch with us on the forum.
Yeah, bring your friends, bring more people. We are excited to meet more people, as always. Yeah. Is that not true? Cool. Okay, this is a bit awkward. Do we just end? Do we just leave? I guess talk for 10 more minutes.
Well, yeah, I think this is the end of it. You can just click leave on the top right, and the session will automatically stop when there are no presenters.
Cool. Okay, bye guys.
Thanks, Mateo. See ya.